What we are doing is assisting the same amount of labor to increase the productivity by a great fold, and the productivity easily 3x, and depending on the complexity of the part, the 3x could be even 10x also. In India, the biggest consumer of carbon fiber products is from the aerospace and defense. Hello everybody, this is Dhinesh here, CEO and founder of Fabheads. At Fabheads, we are revolutionizing the way carbon fiber parts are produced. Carbon fiber, in case you didn't know, is a magical new material that is being used to make very high and high performance materials where lightweight and high strength is required. From simple tennis rackets to actual rockets, satellites, submarines, this material is being used very extensively in the 20th century. But the sad thing is most of these products are still done by manual manufacturing process, and that is where Fabheads comes in. At Fabheads, we have developed a whole new automated manufacturing process to do all these components. And I thank C2Scale for inviting me to be part of the Decoding Manufacturing event. So we are not actually removing labor out of the equation. What we are doing is assisting the same amount of labor to increase the productivity by a great fold, and also increasing the reliability of the overall production process at the same time. So that's essentially what we are doing when we bring in automation, increasing productivity and reliability, not really removing manpower. So it is essentially coming to how we process the raw material into a machine handling format, if I may use that word. So it's essentially like this material processing step that allows us to handle the material in a very flexible manner, and that ensures that it doesn't get broken during the overall fabrication process, and also gives us flexibility to do a lot more innovative activities with it. So Fabheads essentially does automation in carbon fiber products. So if you look at carbon fiber, glass fiber, any of these fiber based products, essentially these are predominantly done by a very manual manufacturing process. It will be very hard for you to believe the huge wind turbine blades that you see. So those are all completely handcrafted. So that is essentially the inherent problem in anything made with carbon fiber based products, is that it's extensively a very manual process. And we have cracked a new manufacturing process that essentially automates it. So this significantly reduces the amount of man hours needed while also increasing the reliability and the production speed. So the moment when we say automation, right, people start thinking that we are going to really eliminate the manpower, but that is not really the case today. The market is so huge today, the amount of manpower that exists are not able to meet the demand of the market today. And that is where what we are bringing in as an automation technology is going to meet that supply gap. So the same amount of manpower will be actually be able to produce a lot more goods with much higher reliability and production speed. So that is what we are bringing into the table. So it is essentially the way we process our raw materials before we feed the materials into the machine. So this material processing step that actually allows our materials to become more flexible and ensures that it doesn't crack during the material processing in the machineries, and also allows us to fiddle with the materials in a great way that actually gives a lot more features for our clients to actually work with. That is one single most innovative step, I would say, that has highest value add overall system. So definitely one of the biggest things that myself and my co-founder Abhijit, during our time in ISRO, we observed is essentially a lot of these carbon fiber products, when we try to fabricate it with areas of the vendors or during in-house, there was a lot of rejection that comes into picture. And this is something that we have personally seen firsthand, and it is not just a problem that is in India, but it is a worldwide problem also. And most of these issues can be actually traced back to inefficiencies in the manual manufacturing process. And also there is a huge gap between how much is needed and how many technicians are available to actually fabricate these and supply. And that is another big gap that today, if only way that is possible to be met is like you train a huge number of craftsmen over say 4 to 5 years, and then maybe you meet the gap, or like by the time the demand would have again grown up further. So the only way to meet it is essentially by automating. So that is where Fabheads came into picture, and not just to supply for the shortness in manpower, but also increase the reliability and production speed. Yeah. So carbon fiber is today used across various sectors. Yeah, robotics, automotive, shipping, biomedical, or some other areas besides aerospace as well. But today the whole market is biggest market for carbon fiber products is actually in aerospace, and that is why inherently we also went, and we also came from an aerospace background. So it was a very easy transition for us. Automotive definitely is one of the biggest sectors as well. But in India, the adoption of carbon fiber is not as great as say in Europe, for example. So being in India, we wanted to have something that we can very quickly validate our tech in within the markets in India. And in India, the biggest consumer of carbon fiber products is from the aerospace and defense. And naturally, that is the reason we chose to go with it. Yeah. So you take any metals or plastics, right? I mean, like the material itself is a very homogeneous material. And what that means is like you take a part, anything that is made out of metal, you take anywhere, it exhibits the same amount of property. So if a designer is making a part with metals or plastic, all they are going to give is just the shape of what the part is going to look like. But in case of a carbon fiber part, it is not that simple. The designer not only gives the shape of the part, but then they have to say in each area of the part how the fiber directions are going to be. So in this area, the fibers have to be in 45 degree, another area of 60 degree, another area, maybe both 45 degree and 60 degree and so on. So they have to go into very high detail across the full structure of the part that they are fabricating, and also additionally give the information on what is the fiber direction in each of the area. And now converting that information, how the fibers are going to be laid out in various areas of the part, has to be very intricate. You cannot just like in casting, just throw fibers at it and expect that the fibers will all magically orient in the expected shapes. So that is why the inherent manufacturing process that we use for plastics and metal doesn't really work for composites. And the only way you can really program on that fiber level in various areas how the fiber orientation is going to be done is today done by only manual process. And that is why it is very hard to actually automate it, because the level of intricacy that is needed to orient each of the fibers in various directions is not something that is so easily automatable. So the first-hand experience for us during our time in ISRO itself helped with that there is a need for robotic demand. So the demand has been there for quite some time. So the only factor that we needed to check was whether the kind of tech that we are developing is going to meet the requirements of the market or not. So that is where during our POC MVP stage, we actually took the market and worked with a lot of potential clients, and also with ISRO, some of our contacts as well. So essentially they gave a lot of feedback in the earlier stage, and to ensure that we were aligned on the direction, what was needed for the market essentially. So we have a very huge tech stack, in fact. So starts from material science. So how the material is processed definitely is one big part of the material, the tech stack itself. And then the machinery that we develop. So in the machinery, there is of course mechanicals, pneumatics, control systems, and a lot of programming of these control systems and the processor. So which does the overall machine management. And then there is also a completely different software stack. So the software that communicates what the user wants to the machine. So basically the user will work on a GUI, and this GUI will convert into a machine readable format. And then there is another software that we have developed that essentially assists the designers in programming how the different fibers in various areas could be, like the way they want it, and also actually assist them in making those fiber orientation better also. So these are a lot of complete tech stack that we have here. So mechanical, electrical, controls, software, firmware, everything. Yeah. Yeah. So the technology that we have developed is essentially the adaptive toe placement. So this ATP is itself like one of the key thing is how the material is adaptively we can control it in the head. So we can adaptively change its form factor during the layup depending on the geometry that it is fabricating. So that is where the core of whatever technology essentially is comes into picture, and how we control that form factor actively across the various geometries that it is trying to lay up. That is where the crux of the fabrication and the core of the technology lies in. So in terms of rejections, like we can decrease anywhere between 20 to 40% depending on the complexity of the part and the existing rejections that are occurring today. And in terms of material wastage, like easily more than 30%, because the way materials are being processed, they use a large sheets from which materials are cut, and then during the material processing itself, a lot of wastage is there, and we completely eliminate that at the source point itself. That way we actually reduce a lot of material wastage besides the rejections that come into picture as well. And the productivity easily 3x, and depending on the complexity of the part, the 3x could be even 10x also. One of the hardest is definitely the material processing tech, but the other more important part is the software layer that comes into picture. Not many people understand that the software is what is going to ultimately let the users understand the value we bring in through all the other technology that we have developed. So the software is going to be the user interface for the customers to make the best use of, extract the maximum value of whatever technology can actually offer. So because this essentially offers a huge variety of fabrication opportunities that you can do, which is never possible with manual manufacturing capabilities, and that is something that you need to use the software, make use of it, and tell the program like, I want the fiber to be laid up like this, I want the fiber to be laid up like this, and it can understand that and communicate that to the machine. So that is a layer which the user will be really appreciative of, like if they go more deep into it and understand what are its capabilities. It was a very conscious decision for us to actually focus on it as a end-to-end rather than just as a manufacturing partner. So we in fact hired a lot of engineers and trained them to be applications engineer, and work with our clients, understand their requirements, and actually assist them with whatever technologies can do, how they can actually improve their designs further. So yeah, I mean, like in many cases, the supply chain team of our clients directly give the products and then we fabricate it and give it to them. But where our clients have extracted the maximum value is when their design team works with our direct applications team, and actually when we gave them design inputs, that has decreased their weight or improved their overall design value in a very big manner, because in many times they don't immediately get what this technology can do, how this particular because it is something new, and it is very understandable that they wouldn't know what this technology is capable of and how they will be able to extract the maximum out of what we are offering. And that is why we consciously ensured that we have a team of application engineers who work with our various designers of our clients, and express them like what is the best way they can extract value out of what we have developed. And that is something a lot of our clients actually find extremely beneficial. And this is kind of ensuring a continuous working relationship for us, right from the design until the production and supply. Yeah, so it's exactly the same. Our application engineering team essentially comes into the fore there again. So when our application engineering team essentially works with their design, because most of these big guys work on very long-term projects, and these where the design and qualification cycle goes for several months, and our application team actually works very closely with their team and goes through those iterations with them, and makes a lot of prototypes and supply them for the feedback, and then continuous loops that we engage with them right from the early development cycle, that they really appreciate and ensures that what we are offering for them actually eases their overall repetitive processes as well. The pricing model for us is very similar to any other manufacturing industry out there. So typically the machine cost that carries over a depreciation based on the time that it serves, and the manpower and the material cost. So those are the three large factors that come in there. And here in this particular case, material cost obviously is going to be one of the major factors compared to the other two. And then we add a profit margin on top of that. So currently we don't add for the special value added services from our engineering team, because that kind of is a acquisition cost that we feel it's good to bear on our own at the moment. Definitely. I mean, like, this is one of the areas where it is very hard to hire, because people don't come right off the college having learned this particular space. So when we try to hire specialized talent for this particular space, we need to look at very smart people and then onboard them and train them up in this particular space. So that typically takes a little period time for us to, until we onboard them and then they become productive for us. And that is in fact one of the biggest challenges that we see. Even to scale up the production floor also, like even the technicians that we train, the typical ITIs, they don't ever get trained in composites. They typically get trained in typical CNC machines and not really the machines that we develop, because these are fairly fresh, of course. So again, there is a little bit of training over there. So that has been the major hurdle for us to quickly, whenever we want to quickly ramp up our capacity, hiring the people and getting them trained and quickly making them ready for our production flow. But yeah, right now we are having a in-house training team who are kind of like, running as a churning for manpower. Yeah, as I said for the last question, so there is no trained manpower here, unfortunately. But we pick up talent. Let's say in R&D team, for example, we pick up talent who are very highly skilled in mechanical and control systems, and then kind of use their existing skills to apply to develop a new mission that they've never come across. So the overall vision of it comes from our management team and our CTO team, and then that vision gets translated into what people see, and then it is purely they look at it as an engineering challenge and go about it. But from an operations angle, they need to have that experience on what it is, how these materials work, and how, let's say, even from a quality guy, when we hire, if he has not worked in the particular sector, he wouldn't know what to look for it. So all this we need to have a in-house 2 to 3 months of extensive training that we offer, where they get trained over these particular things and then go on. But for us, because it is such a very rare sector that we work in, we don't see it any other way around. We have to hire the best talent and then train them up. So I wouldn't say particularly failed, but the project went on forever, where we probably should not have taken such projects in a very early stage, sort of something that we should have pursued a little later, sort of. But it really burnt a lot of our resources too early. But other biggest learning, I would say, is typically in terms of the business model itself. So when we were just getting into the commercialization stage, we were not able to decide whether to go as a manufacturing as a service model or to sell the machines as a machine sale model. So that time we kind of experimented both at the same time, and got a idea of which is going to be better. So we observed that when we are selling the services as a manufacturing as a service, we are able to offer higher value addition to the client. When we did some mission sale, people were not able to, even if they buy the mission, they are not able to extract the maximum value out of the mission, because they didn't know how to use the machinery. And that was a very big learning for us. So we pivoted very quickly to a point where we moved primarily towards just as a manufacturing as a service company. And that was a very huge learning for us in the very early days of our commercialization. Yeah. So for composites, when we started working on, so there are a lot of sectors that we have, like aerospace, defense, robotics, automotive, shipping, and basically we had to see which is the area that we can crack very quickly, and also people are have the dire need right now. So in automotive, yes, there is a requirement for composites, but not as dire as in say aerospace. In aerospace, people are already using composites extensively and are suffering because of various rejections and lack of high quality supply chain and even lack of supply also. And that is where we were able to very quickly get in and meet the clients and convince them very quickly that what we are offering is a better alternative to you compared to say purely manual manufacturing process. So that was a very easy conversion. But let's say if I'm going into biomedical, for example, say titanium implants over carbon fiber implants. Titanium implants are still very solid, like carbon fiber implants are superior, yes, but why would they want to change it? Like they don't have that huge necessity for a change right away, right today. That much of a demand wasn't there. So though it might happen say 6 years down the line, 7 years down the line, but will that happen right now? Definitely not. So that is kind of how we decided which is the first few sectors that we need to focus and which could be somewhere down the line. Typically in the early days of when we start, I didn't really think like software would still play that bigger role in today's what we are doing right now. The SASIC software that we have built actually plays a very big role in actually conveying to the clients, because the our clients don't interface with the machines, right? They interface with the softwares, and then they kind of simulate the overall like how the machine is going to work typically on the software ecosystem itself, and understand what they can extract maximum value addition out of it. And we are also trying to build an AI layer to it and make it a lot more design friendly and kind of give the designers a lot more options before even they get into the next stage of overall design process. So I think we really underestimated where the software and the AI part could actually increase the overall value addition of what we are developing from the hardware side of things. So every one of those, of course, 5 years is a very short time. So we will start off with aerospace, of course, and we want to have a very good capacity to supply to international supply chains as well within the next 2 years of in the aerospace circles, and slowly get into shipping and robotics in a very big way. Down the line, say 5 to 6 years down the line, we would be probably getting into biomedical as well. But for the time being, we are focusing on getting into more and more into aerospace across various geographies, and then slowly into shipping and robotics, and then slowly a geographic expansion in that particular areas also.